Okay, so this is a question about a mass on a spring. So a mass weighing 16 pounds is attached to a spring whose constant is 8 pounds per foot. Okay? The medium offers a damping effect that is numerically equivalent to 4 times the velocity. All right? And determine the equation of motion if it's released 1 foot below equilibrium with downward velocity of 2 feet per second. Okay, let's see what this problem is offering us. So this is the equation that we're looking for. Okay, so a mass weighing 16 pounds. So if you want to figure out what mass is, that's going to be weight divided by gravity. So M is going to equal now 16 divided by 32, which is 1/2. Okay? All right. Now, let's look at this. Okay? Whose constant is 8 pounds per foot. So we don't have to divide by anything. So we're just going to say K is going to equal 8. Okay? All right. And then the next part of the problem says, the median offers a damping effect that is numerically equivalent to 4 times the velocity. Okay? So that's our beta. So beta is going to equal 4. All right. Let's see what other information is given inside of this problem. So, all right, it's released 1 foot below equilibrium. And now remember, when it's below equilibrium, this seems a little contradictory, it's actually positive, okay? And it's headed downward, so it's heading in the positive direction. So if it's released 1 foot below equilibrium, that tells me that x of 0 is going to equal 1. And it's released with a downward velocity of 2 feet per second, so that says that x prime of 0 is going to equal 2. Okay? So this is all the information that's given inside of the problem. We have mass, the spring constant, the beta of the dampening effect, and the initial condition of the placement of the mass and the initial velocity of mass. So let's put all of this together. Actually, let me separate those. So we end up with 1/2. Now the second derivative. Anyway, all right. So beta was 4. And k is 8. Okay. All right. Let's get this in standard form by multiplying everybody by 2. So this auxiliary equation is going to be m squared plus 8m plus 16, which equals 0. Okay? Well, like on the previous problem, this is m plus 4 squared, which equals 0. So m is going to equal -4 twice. Okay. So let's take the X's. So that tells me that x of t is going to equal c1 e to the -4x t. Sorry. All right, now plus c2 t e to the -4t. Off the screen. Now we're going to use our initial conditions to solve for C1 and C2. So let's do the easy one first. X of 0 equals 1. So 1 is going to equal C1 plus C2 times 0. Okay, so C1 equals 1. Okay. All right, now x prime of t would be negative 4. We already know that C1 is 1. E to the minus 4t plus C2 e to the minus 4t. We don't have to do the product rule on this. And then minus 4 is a C2t e to the minus 4t. Okay? And it said that our downward velocity was 2. So x prime of 0 equals 2. So 2 is going to equal now negative 4, and that's e to the 0, plus C2, and then minus 4C2 times 0. Okay, so that right there is telling me I don't care about the 0. If I move the 4 over to the side of the problem, C2 equals 6. So, x of t equals e to the minus 4t plus 6 t e to the minus 4t. And that is the solution to our problem. And that's the equation of motion of that mass on that spring.